Here's just a quick follow-up to finish an example that was started in class from the homework, and more specifically from Chapter 9, Hypothesis Testing for a Single Population Mean. So if you want to take time, pause it, reread it. But essentially we pulled the data by just copying and pasting it. I'm going to use our Google Sheets page, but you can pretty much do this in your calculator or by hand. We need to find the average, so we're going to I'm going to paste them as values here. It didn't recognize them as into individual cells, so I'm just going to simply click on the cell again, Control V for paste, and then choose to split them into columns. I need to select them all. I Control C copied those, and then I'm going to paste them transposed. So I'm right clicking and pasting transpose. This is just one way of doing this, but since they're selected now, I Control C that. I go back up and right click, paste special as values. That way I don't mess up any of my formatting or my formulas. I've got a sample mean now, a sample standard deviation. I verify my sample size, so I think I'm good to go. So I wrote down those statistics, and I know that I'm going to use the t-distribution because the sigma was unknown, and we're just using the sample standard deviation. These are all some of the things that we already talked about in class. Anyhow, so I need to get the standardized test score for that t-distribution. So here's my test statistic, which is the deviation divided by the standard error. And I can make this real easy on myself by just using GeoGebra. Once I have the summary statistics, I can just click on the Statistics tab and be sure to open the right type of test. Or estimate, whatever I'm doing. So estimating was what we did when we were doing, started with point estimates and then turned them into interval estimates. So that's confidence intervals right there, the previous chapter. We're doing hypothesis tests, and we're doing hypothesis tests of a single population. So if they're finding a difference, those must be using two populations, right? So we're looking for one of these single population ones. This is a test about proportion, and of course you're going to use the z-distribution. Here's a test about mean, but so is that. The difference between the two is one is when you know sigma, and the other one is when you don't know sigma, which is certainly our case because all we had was the summary statistics. So I'm going to plug in my null. Got to make sure I've identified my alternative. So my alternatives are not equals. And then while I'm here, I'm just going to make sure 38, 54, and 54289. So it's a not equals, which is already selected by default. My mean was 38, 545454. 5.4288 something turns out to be 89. Sample size 11. It'll do all the work for me, run those calculations, and when it puts out these results, remember that this is the test statistic and this is the p-value. So I've got my test statistic of 0.944. Now that's pretty close to 0, so it's pretty close to the center. And that's going to give me more p-value. Remember to consider it this way. You're running a two-tailed test. So you're going to have area split up. This is going to give you one on the positive side, say right here. But we're going to double it since it's a two-tailed test, so we're going to think of that one. And we're going to get a bunch of area. I know it's not to scale, Should be a little skinnier, a little taller, but you can see how we're going to get 37%, which is a lot, relatively speaking. How strong was our test supposed to be? Well, that was given in the problem, I suppose. Let me go find that. There it is. Even though our test was pretty loose, it was 10%. We're still well over that. So maybe the critical values turned out right here, and so the alpha was 10%. But we're going to compare our p-value to alpha. Numbers turned out 0.3673 compared to 0.1000, 10%. Remember that we reject the null if the p-value is less than or equal to alpha. The p-value is bigger than alpha, so we will fail to reject the null. We're going to fail to reject the null, and then we'll get our final wording in this way. Since our original claim did not contain the condition of equality, we're in these two rows right here, and since we failed to reject the null, we will not support the original claim. And then now we're just left to state our conclusion in some non-technical terms. By the way, the change of slide occurred because I had a bit of a computer malfunction and lost my other page. So anyway, go back to the original question, since it was a two-tailed test, and the claim was that the average number of haircuts for college students is different, so that it, in other words, it differs, it's less or it's more than the 37-day average of Americans. Then what we're going to say is we don't have sufficient evidence to support the claim that the average number of haircuts, average number of days between haircuts for college students is 37. We can now just start pumping those responses into the solution, or to the homework. So it's a t-test. Read carefully through these conclusions. Well, it looks like I've had 2 glitches in one video. So no worries. This was the original problem, and that's how I worked it out. Hopefully, if you'd like to return, watch the video over, pause, and collect the information that you need to try it on your own and compare. But I did select all the right answers and put everything in correctly. All right, hope that helped.